Hey everyone, hope you guys had a great weekend, enjoyed it. So what I want to do is just create this video going over each one of these problems from this first review to help you guys get ready for that quiz coming up on Thursday this week. All right, so I know I just took this from a review I did in class. That's why it doesn't start with like number one. But let's go through and solve these, and then at the very end we'll go ahead and graph them. And then if you guys have any questions, always just reach out to me. All right, so the first one, let's start with number 12. All right, so for number 12, you guys have 2 times the third root of x minus 3 is equal to 4. So when you guys are working with these problems, you always want to try to get what's in that root by itself on one side. So in this case, since you see a third root on the left side, you want to divide by 2 first to get rid of that 2. So that'll leave you with the third root of x minus 3. And then obviously we have to divide the right side by 2 as well, is equal to 2. All right, so once we're here, now what we have to do is we have to get rid of that third root symbol. So what we can do, just like if it was a square root and we square both sides, well now since it's a third root, we can now raise that to the third power and it'll cancel out. But whatever we do to one side, we have to do to the other. So that means on my left side, I'm just going to be left with an x minus 3. I don't know why that doesn't look good. Hold on. All right. So we have an x minus 3. On my right side, we know 2 to the third ends up giving us 8. All right, now at this point, we just add 3 to both sides, and we end up getting that x is equal to then a positive 11. All right, so let's look at 13. All right, so 13 is really similar, where we want to get the radical by itself and then maybe square or take a third root, whatever we need to do. So on number 13, when you guys see that radical or that square root on the left is by itself, that's exactly what you want. Now, after that, you want to try to get rid of it, right? So the way that we're going to get rid of it, just like we got rid of our third root on our last problem, is we're going to have to square it. But if we square the left side, that also means I'm going to have to square the right side. So by squaring the left side, we're just going to be left with that 10x plus 9. Be really careful when you guys are squaring this right side. When you square x plus 3, remember what that really is saying is that we really have 2x plus 3's. So we want to take these x plus 3's and we want to write them out twice, because this tells us that we are going to have to be able to FOIL. All right, so my left side is going to say the exact same thing. We have 10x plus 9. Now on my right side, we want to go ahead and we want to try to FOIL that. So when we do, it's going to give us x squared plus 6x plus 9. All right, now once you guys are here, you need to solve the equation. Now, since you have x squareds and x's all in this equation, let's get everything to one side, keeping that x squared positive, and we're probably going to have to try to factor in order to solve this one. So if we subtract a 10x and subtract a 9 on both sides, we're going to have 0 is equal to x squared minus 4x, and the 9's end up actually canceling out. So that's all you have. All right, so now that you're here, you're going to have to try to factor. So especially since we see that x squared, sometimes when we factor, it's just taking out a GCF. So we can take out a GCF of just x, which is going to leave us with an x minus 4. All right, now at this stage right here, you guys have your two groups, right? Like you have your GCF, and then you also have that x minus 4. So each of those two groups, we're just going to set equal to 0 and then try to solve. So when I set x equals 0, it's just going to give me 0. And when I set x minus 4 equals 0, that's going to give me a positive 4. Now remember, because you guys ended up squaring both sides, just make sure you check for those extraneous solutions by plugging things back in to make sure it's still true. So when we plug the 0 back in for x into our original equation, we would end up getting the square root of 9 is equal to 3, which is true. If we plug the 4 back in, we would get the square root of 49 is equal to 7, which is also true. So in this case, both of these answers work. It's going to be 0 and a positive 4. All right, so let's look at 14. So on 14, you guys have the fourth root of 4x plus 1 is equal to the fourth root of x plus 10. All right, so when you guys are going through and you're solving this one, if you remember from last week, these were the ones I pointed out, which actually might be the easiest type of problems. Whenever you see like a square root equaling a square root, or in this case, a fourth root equaling a fourth root, and you try to get rid of that fourth root or that radical symbol by raising something to the fourth power, when you raise the other side to that same power, you're going to notice your radical signs just really drop off or cancel out. So the only thing that you're left with then is what's left underneath that radical on the inside. So you have a 4x plus 1 is equal to an x plus 10. And from there, it's just like solving a normal equation. So let me subtract my x's to the left side. I'll subtract a 1 to the right side. And we'll divide by 3. And we end up getting that x is equal to a positive 3. So as long as everything is underneath that radical symbol, it's going to be really nice and easy. Everything just drops off, and then you just solve that simple equation. All right, now number 15 is a little bit different, and this is the one that a lot of you guys, when you submitted that homework from last week or that assignment, a lot of you said you kind of had a little bit of issues with this one. So the reason why 15 and 14 are so different is because of this minus 2. That minus 2 is outside of your radical sign, so that's going to kind of cause some issues. All right, so the first thing that we want to do is attempt to get rid of these radical symbols, right? So if I notice that on my right side of the equation, I just see a square root, well, let me try to square that side to get rid of it. But just know if I square the right side, I'm also going to have to try to square the left side. Okay, now when you guys square the left side, just like we talked about on problem number 13, or this problem right above it, when you're squaring it, you really want to write out like what it's representing. So I'm actually going to write this out twice. So I'm going to have the square root of x plus 6 minus 2 times the square root of x plus 6 minus 2. All right, and my right side is just going to be x minus 2. Okay, so when you guys are here, and I think this is the part that we're kind of having a little issues with, this, when we write this out twice, this side over here, this is when you guys are going to have to be able to FOIL again. Now, when you FOIL, you got to think about like multiplying 2 terms times 2 terms. So think about the square root of x plus 6. That's the first term in each parenthesis. And then the negative 2 is going to be your second term. So I'll do this one all in kind of a different marker, this green color, to help you out, because I know this can be a little bit tough. So when you guys go to multiply your first terms together, you have the square root of x plus 6 times the square root of x plus 6. The square root of anything times the square root of itself will just leave you with what's underneath the radical symbol. So by multiplying my first terms together, that just leaves me with an x plus 6. Now if I go to my outside terms, the square root of x plus 6 times negative 2 means I'm just throwing that negative 2 out in front of that square root symbol, but I still have my x plus 6 underneath. Same thing with my inside terms. The same exact thing happens. All right, and then my last terms, I have a negative 2 times a negative 2, which is going to end up giving us a positive 4. All right, so if you guys need any help with that foiling step, please let me know. I try to walk through it as slow as I could and explain it to you. But if you're still kind of struggling with how we're multiplying those things out, just email me, comment me, just let me know. All right, so now once you guys are here on this left side, and I'll go back to red. On this left side, you want to try to now condense this left side as much as you can, which means that when you start to see some like terms, you're going to add your like terms together. So that x can't be added with anything, but we know the 6 and the 4 can add together to now give us a 10. And we actually know that we can add radicals too. And as long as the same thing is underneath each radical, that means that they're like terms. And all we're going to do is add their coefficients together. So in this case, when we add our coefficients together, we end up getting a -4. But that square root of x plus 6 is going to stay the exact same, because that's how we know how to add radicals. And then that'll be equal to an x minus 2. All right. Okay, so once you condense that left side, now you want to look to try to see if you can get this square root symbol by itself on that left side, because then we want to square both sides again and kind of go from there. So that means I'm going to subtract an x on both sides, and the x's are going to cancel out. And I'm also going to subtract a 10 on both sides. So that'll leave me with a -4 times the square root of x plus 6. Our x's cancel out, and then we're just left with a -12. Okay, so once you guys have this, again, you're trying to get that square root by itself. So in order to get that by itself, that means you're going to have to divide now both sides by -4. All right, so I'm actually going to do some work over here. Okay. All right, so once you guys divide both sides by -4, you should be left with the square root of x plus 6 is now equal to a +3. All right. Once you guys are at this step, now you're just really looking to get rid of that radical symbol. Or in this case, it's the square root by squaring both sides. So that'll leave us with x plus 6 is then equal to 9. And then when we subtract 6 on both sides, you end up getting that x is then equal to a +3. So again, just like we talked about, guys, just check for extraneous solutions. So in this case, when we go through and we plug the 3 back in, the left side will equal the right side. So we know this is okay. This is going to give us our final answer of just x is equal to a +3. All right, so let's go down and look at our last two equations, 16 and 17. So 16 and 17 are really similar because you guys are going to start to see those exponents now being fractions. Okay. All right, so another common mistake that I saw in that assignment that was submitted last week is not getting like whatever's being raised to that power by itself first. You always want to do that first before you even worry about getting rid of the exponent. So like, for example, if you look at number 16, you need the only thing that's being raised to that 3/2 or 3/2 power is x. The 3 isn't being raised to it. So what we have to do first is we have to try to get rid of the 3. So we're going to divide by a 3 on that left side first, which means we obviously have to divide by a 3 on that right side too. So that'll leave us with x to the 3/2 is then equal to 125. All right. Okay, so now that you finally have x by itself, now this is when you want to go through and think about how you're going to get rid of your exponent. So remember, we talked about this last week. In order to get rid of our exponent when it's a fraction, what we really want to do is we really want to multiply by its reciprocal. Because when we multiply a fraction by its reciprocal, it gives us just 1. And since it gives us 1, we know since we're trying to solve for x, well, we want x to the first power because it's just x. So we're going to multiply by 2/3. Now, if we did that on the left side, remember, you're also going to have to do that on the right side, but you're not multiplying 125 by 2/3. 125 really right now has an exponent of 1. And the exponent of 1 is what you're multiplying by that 2/3. So you end up getting that x is equal to 125 to the 2/3 power. All right. Now, once you're there, now you can use your radical form to rewrite this to then try to actually get what the answer is. So when we're going to go and rewrite this, we're going to move our denominator out in front. So it's going to be the 3rd root of 125. Our numerator is going to be our power, so it's all to the 2nd power. We know that the 3rd root of 25 is just 5, so it ends up being 5 to the 2nd, and then 5 to the 2nd we know is just 25. So our final answer for number 16 ends up being 25. Okay. All right, so it's really similar with number 17. So I'm just going to go ahead and erase some of this last couple steps on 16, just so I have some room to do problem number 17 over here. All right, so when you guys look at 17, really, really similar. Now, just notice the only thing that's being raised to the 1/3 power in this case is the entire group of x plus 2. So that means that you want to subtract a 3 on both sides first. So you're going to have x plus 2 to the 1/3 is equal to 4. All right, so once you have that step, now you guys want to try to get rid of your exponent. So if your exponent to 1/3, that means we want to multiply by the reciprocal of, in this case, it's going to be 3/1 to get those to cancel out. So that means on my left side, we're just going to have an x plus 2. Now, when we multiply that 3/1 by the right side, remember, you're multiplying 4's exponent, which is a 1. So I'm going to multiply this 1 by 3/1. And 1 times 3/1 is just 3. So we end up getting a 4 to the 3rd. So then at this point in time, we want to actually simplify that right side before we get x by itself. So we know 4 to the 3rd ends up giving us 64. So now once we have this, now we're going to go through, subtract 2 on both sides to get x by itself. And this is going to give us x is equal to 62. And there's our final answer. All right, so those were all the equation problems that we had. So the next type of problems that we're going to see is what we talked about on Thursday of last week, where we're actually going to go through and we're going to graph these radical functions. Okay, all right, so let's start with 18 first. So if you guys remember, the first thing that we want to do is we want to get our starting point. Now, our starting point is going to be like an ordered pair. And it's always going to start with whatever's opposite underneath the radical. That'll be your x value. And then whatever's outside of the radical, that's going to be your y value, which in this case is going to be 0. So what that means is we start at -2, 0. So I'm going to go to the left 2. And that's going to be my 1 point. Now, after I have that 1 point, now I want to use a, or that value in front of my radical, as slope. So if I look out in front, I see a -3. So what that tells me is from that first point that I drew, I'm now going to go down 3 units, and we always run to the right. So I'm going to go down 3 and to the right 1, and that's going to be my second point. And then remember what these look like? These just look kind of like a curved line moving off to the right that end up leveling out towards the end. All right, so it ends up looking like this. All right, so let's look at 19. All right, so same thing with 19. First thing is get your starting point. So when we get our starting point for this problem, I look inside my radical and I look outside of it. So if I look inside first to start, well, there's nothing with x on the inside. So that means my x value is just going to be 0. On the outside, I see a positive 1. So that tells me that I'm going to go up 1 unit, and that's going to be where my first point lies. Now, if I look at my a value, or that value out in front of my radical, there's really a 1. So that means from that point, I'm going to have to go up 1, and we always run to the right, so we're going to go to the right one. So I go up 1 to the right one. That gives me my second point. I go up and over, and then kind of level this out as we go off to the right. All right, on number 20. Same thing. First, let's get our starting point. Now, we just talked about if nothing's underneath the radical with x, which in this case, like again on 20, it's not. It's going to be our value of 0 for x. If we look at y, same thing. There's nothing on the very outside. So since there's nothing there, it's going to be 0 again, which tells us that this graph isn't moving left or right at all. So my point is going to lie right on the origin. Now, if I look at that value out in front of my radical and I see a 2 and it's positive, that means I'm going to go up 2 and I'm going to go to the right 1. So we're going to go up 2 and to the right 1, and that's going to be our second point, which again just kind of stretches this out vertically a little bit. All right, last one we see is 21. So when we go through and we get our starting point first, if we look at the opposite of the inside, that's going to give us a positive 1. If I look on the outside, keep that sign the same, that'll give us a negative 2. So that tells me I'm going to the left 1, and then I'm also going down 2. And that'll be my first point. Now, if I look at my a value, I see that that's really a negative 1. So that means I'm going to go from my point down 1 and to the right 1, and that'll give me my second point. So then I'm just connecting those 2 points and then trailing off to the right. All right. Oh, wow. I'm sorry. I hope you guys caught me when I was doing this. All right, I actually graphed that wrong. Let me go back and do that. So because my starting point is 1 comma negative 2, not negative 1 comma negative 2, I needed to move to the right 1 and then down 2. I'm sorry. And then we're going to do the same thing since our slope is negative 1 over 1. There we go. All right, so hopefully you guys caught that when you're watching this video. Just testing you. All right. If you guys have any questions on this stuff, please let me know. Available anytime today. Just shoot me an email or comment through Google Classroom, and I'll be able to respond to you to help you guys out. All right. Have a good rest of your day.